What if, right nearby in space, just beyond the outer edge of the Kuiper Belt, somewhere deep in the Oort cloud, at a distance of, say, half a light year, a black hole is hiding? Despite the distance of half a light year, this is still within the boundaries of the solar system. And for us, such a neighborhood, frankly speaking, is undesirable. But if it did happen, what could we do? Perhaps for the time being, nothing except one thing. Closely observe it, if of course we know where it is, and detecting it in a passive state, oh, that's not easy at all. Or maybe out there in the black void of space, a huge alien ship is hidden, sending its scouts to us? Who knows? Hello everyone, you're on the Age of Disbelief channel with Mikhail Kamikov, and today we'll try once again to dive into the mysteries of space and our nearest cosmic surroundings. On my channel, we've already discussed such questions more than once in relation to various cosmic bodies and phenomena. We've touched on the moon, its features and the reasons for its appearance more than once or twice. And we've also paid attention to meteor showers several times. For example, in the video, Silent Witnesses, I explain from the point of view of celestial mechanics why this is the case. The very fact of the existence of such streams and their strict periodicity is indisputable evidence that a gigantic catastrophe occurred in Earth's orbit in the recent past, tearing apart one or even several celestial bodies into small pieces, which later became short-period comets and asteroids. In the video, That Very White, a calculation of their trajectories is provided, and a fairly precise location of the explosion is indicated. Evidence of this is also the huge number of small satellites of Jupiter and Saturn. All of them were captured randomly from different angles of attack to the plane of the ecliptic, which also indicates the chaos that occurred at that time. And the existence of residual field rings around the Earth also explains the strange flickering of the sun, as well as its sudden disappearance in certain areas, which is also described in more detail in the video, the day when the sun went out. And so, as if to indirectly prove the validity of my conclusions, a little over a year ago, on December 25th, 2021, the newest space telescope, James Webb, was launched. It was successfully launched, and exactly a month later, on January 24th, 2022, it reached the required point. It turned out to be the Lagrange point of the Earth-Sun system, thus remaining under the constant protection of the Earth from solar radiation. A few words about this orbital point itself. What is this L2 and what makes it remarkable? And this is one of the 5 Lagrange points in the Earth-Sun system, where an object that gets there can remain for quite a long time, practically without any effort. There are 5 such points in total, and the most stable among them are points L4 and L5. Here they are. In these points, the gravitational forces of the Sun and the Earth are perfectly balanced. The other points are not as stable. And to maintain the orbit of a satellite located there, engines are still needed. An interesting nuance. When you start to take a close interest in how these points work, looking for relevant videos or articles, if you're a humanities person, there's almost 100% chance you won't understand how it works. Practically on all resources, you will be presented with the same graphs and diagrams, which will only confuse you even more. I don't know if scientists do this on purpose, but just imagine a graphical diagram like this. It shows zones in the intensity of gravitational fields, and at the Lagrange points, they appear as if they are elevated above the landscape, like a mountain. In this way, a humanities major will inevitably be baffled. How is that? I see a hill, but I'm being told that an object won't roll off it anywhere.
It's like this. The potential of such a system can be represented as a double hill, like this shape. The two deep pits are massive bodies. Here are the first three Lagrange points, and the highest peaks are exactly the fourth and fifth points. So, it's all an analogy, but I couldn't come up with anything more visual.
Moreover, any engineer will passionately argue that you're an idiot if you don't understand such a simple truth. Actually, if you turn the graph inside out, everything will become much clearer. And this is actually part of the conspiracy. No, of course, the scientists themselves aren't actually conspiring about anything like that. However, I'm sure they enjoy making fun of humanity's majors in this way. It's pleasant, it tickles their ego, and makes them think about their own superiority. Simple pride. However, in reality, something much more serious is happening. There is a growing divide between humanities scholars who are able to grasp the big picture and abstract away from nuances and details, and technical specialists who can't see the whole picture beyond their microscopes and other measuring instruments. It's like separating the right and left hemispheres of a single brain. As a result, such a person can easily develop schizophrenia and won't be able to make the right decisions simply because he doesn't see the whole picture. Actually, that's exactly what we're observing in the world right now. But however, I'm getting sidetracked. Let me explain how a specific Lagrange point works, and after that, try to compare it with the explanation that's offered in all the science videos, articles, and Wikipedia. So, look, here's the Earth, a massive object with its own gravity, rotating along a certain orbit around another object, the Sun. For the Earth to move stably along its path, the Earth must have a certain speed. In our case, that's about 30 kilometers per second. This speed allows the Earth to remain in a stable position on its specific orbit. If the Earth is closer to the Sun, this speed won't be enough and we will fall into the Sun. If the Earth is farther away, the speed will be too great and we will fly off into the endless expanses of the universe. That is, this speed is stable specifically here and specifically for an object like the Earth. I hope everything is clear so far. Now let's imagine that next to us, at some hypothetical distance, there is another object flying with a much smaller mass. It is also flying in orbit around the Sun. But since it is just a bit farther away, its orbit is longer, and its flight speed is slightly less than our 30 kilometers per second. Everything is clear here as well. And now imagine that the Earth has a gravitational field with which it influences this object. Of course, the object will experience the Earth's gravity and at the same time fly in orbit around the Sun. The Earth's gravity will constantly pull it toward itself, knocking it off its orbit, and will either make it fall or, on the contrary, accelerate it and throw it farther out into space. So, a Lagrange point is such a place and at such a distance from the Earth where gravity balances itself out. At first, it pulls the satellite, accelerating its movement, but then, when it gains speed and tries to overtake the Earth, on the contrary, it starts to slow it down. It turns out as if the satellite is tied to the Earth with a rubber band and makes oscillating movements back and forth, back and forth. And although the force of gravity pulls it in one plane, the movement of the satellite itself becomes somewhat ellipsoidal. Yes, try it yourself. Take a rubber band with a weight in your hands and try pulling it back and forth, back and forth. As a result, the weight will start to rotate. You get a kind of orbit with an empty space in the center. This is the Lagrange point. However, let me remind you that it is still not completely stable. Sooner or later, one of the forces will win, and the satellite will either be thrown into space or pulled down to Earth. But how do you like this explanation? It's much clearer, right? However, astronomers and physicists seem to do everything possible to make things as confusing as possible. But let's get back to our space telescope, James Webb. So, 4 months after launch, reaching the required orbit in numerous preparatory operations. May 9th, 2022, our magnificent telescope was put into operation, oriented toward its first target, and began taking its first high-quality images. And right then it got hit by a meteorite on the C3 segment of the mirror. That is, almost immediately, after just 2 weeks of operation, from the 22nd to the 24th of May, this damage was recorded. And this is where things start to get strange. On one hand, the National Aeronautics and Space Administration report claims that it was a micrometeoroid and that it had only a minor impact on the overall operation of the entire telescope. But if you Google what a micrometeoroid is, you'll get something like this. That is, it's cosmic dust, which you can only see under a microscope. On the other hand, in the same National Aeronautics and Space Administration report, it says that the mirror hit by this dust particle was irreversibly destroyed, meaning it suffered irreparable, fatal damage. And at the same time, you have to remember that this very mirror is almost 1.5 by 1.2 meters in size. In fact, to be precise, it's 1.32 meters. And you want to say that a micrometeoroid destroyed a mirror that was originally designed to withstand micrometeoroid impacts, made from a special beryllium alloy and coated with a microscopic layer of gold? Yes, of course. Beryllium is a very brittle metal. But still, it's hard to believe that such a large plate with an area of almost 2 square meters was destroyed by a speck of dust. They were still preparing for dust particle impacts. Well, okay, maybe I'm just exaggerating the situation. Moreover, the loss of one such mirror actually had an insignificant effect on the operation of the telescope. After all, it still had 17 more exactly like it, each of which changes its position under the control of 3 drives at once. The loss of one of the 18 mirrors was simply compensated for. This can be endured. The problem is that no one expected meteorite impacts to occur so quickly, which in turn once again suggests to us that there might be a field disk orbiting the Earth. And not just one. Some people might object right now saying, but what did you expect? This is the Lagrange point after all. A lot of space debris is supposed to accumulate here. That's true, but I didn't explain the mechanics of the Lagrange points at the very beginning for nothing. In particular, this point is unstable, and no debris can accumulate here for long. For that, the debris would need to have its own engine. Well, one thing is certain. It definitely wasn't a meteor shower, as the National Aeronautics and Space Administration employees themselves claim. It was supposed to be a completely random, inevitable event, but maybe it wasn't so random after all. Judge for yourself. The device had been at the Lagrange point for 3 months, and nothing bad had happened. But as soon as it targeted the object and started taking the first pictures, something hit it. That is, it came directly from where it was looking. And here we need to find out, where exactly was it looking? Let's take a look at its very first photo. Here it is. This photo has already caused a lot of buzz, but now, a year later, it wouldn't hurt to refresh it in our memory. So according to astronomers, the photo shows a cluster of galaxies with the codename SMACSJ0723. Well, a cluster is a cluster. What's so unusual about it? Just one detail. The photo clearly shows the effect of gravitational lensing, which is characteristic of objects with very strong gravity. Basically, it's the effect of a gravitational lens. That is, the deflection of light rays from their straight path is characteristic of all massive objects, stars, our sun, and even the Earth. However, the smaller the mass, the smaller the deflection of light, and the less noticeable this effect is. For example, with our sun, it is noticeable only in a rather narrow band between its surface and space. And to measure it on Earth, you would need extremely precise equipment, but nevertheless it exists. In the image, however, a very large area of lensing is visible, but the object causing it itself is not visible. But how is it not visible? Astronomers are trying to convince us that this cluster of galaxies in the center of the lens is what causes it. But something doesn't add up. First of all, it's the size of the lens itself. It's not just huge, it's of incredible proportions. Inside this lens, there are dozens, no, not even stars, but galaxies. That is, if you compare the size of the lens to the size of these galaxies, you get an object with a diameter of millions, if not billions, of light years and a corresponding mass of millions of galaxies. Either it's not quite what it seems. And in fact, although the object does have a colossal mass, it is actually much closer to us than we would like it to be. Literally right next to the sun, somewhere within the Oort cloud, inside it, that is, at most 1 or even half a light year away. But according to the inverse square law, the closer this object is to us, the larger the visible area it occupies. In this case, not the object itself, but its gravitational lens. Very, very close. And at the same time, this object is completely invisible. Let me remind you that there is only one object in the universe that fits this description, and that is a black hole. Moreover, the effect of gravitational lensing is currently the only way to detect a dormant black hole. But maybe I'm exaggerating again and seeing what I want to see. Let's see if a similar lensing effect is observed when photographing other galaxy clusters. It's not the only one in the universe. Well, here you go. Here's a galaxy cluster in the constellation of the Pump. There are galaxies. There's a cluster too, but there's not the slightest hint of gravitational lensing. Here's a galaxy cluster in Hydra. No lensing there either. And here's a galaxy cluster in Ursa Major. Do you see any gravitational distortions? I don't. And here's just a massive galaxy cluster. 2744, or the Pandora cluster. There's no gravitational lens, even though the cluster is larger than the SMACS cluster. 0723. This list could go on for a long time, and sooner or later, noticeable effects of gravitational lensing periodically appear in it. But they are also explained in different ways, sometimes by a cluster of galaxies, sometimes by a concentration of dark matter. Sometimes they admit that yes, it is a black hole, but the examples given are enough to understand that a cluster of galaxies and the lensing effect observed by the Hubble Space Telescope have nothing in common with each other. On the contrary, in 99% of cases, it is exactly a black hole. That very passage, which has caused numerous catastrophes over the past 500 years or more. And for scientists, its existence is clearly not a secret. Just think about it. If you knew about the danger posed by such a neighbor, wouldn't you set up hidden and continuous surveillance to track even the slightest changes in its behavior? I think so, yes. And in fact, this very place was the very first target of the James Webb Telescope. A tiny, unknown cluster of galaxies in a small, little-known constellation called the Flying Fish, located in the southern hemisphere. That is, in a place where most people on the planet won't even be able to look. And it was exactly this that was the first target of the telescope. But perhaps this is merely coincidental? No. This cluster was closely observed by the Hubble telescope, and before that by the Planck astronomical satellite, and before that by the Chandra X-ray Observatory. That is, this object has been under the close attention of space observatories since 1999. Asteroids. Now let's recall how we modeled the passage of this object in previous videos from the Earth Axis series, and compare it with what we are observing now. So I assumed that the object was passing through the solar system from the northern hemisphere to the southern at a slight angle, closer to the Kuiper belt, somewhere beyond Uranus's orbit. Passing by us so closely, the solar system and the black object performed a gravitational maneuver relative to each other. And as a result, the sun, along with us, changed its ecliptic plane in the galaxy by about 20 to 30 degrees, while the object continued its movement downward into the plane of the southern hemisphere. If we look at the orbits of transuranic objects and asteroids in the Kuiper belt, we will see exactly such a deviation downward toward the south. It was there that a stronger body was located, which attracted the nearest objects to itself. For example, the dwarf planetoid Asteroid, its orbit seems to be stretched by something exactly downward, toward where the cluster of galaxies is located. The dwarf planets Oumuamua and Makemake also have similar orbital deviations, and so do many others. Learn more about this in the video series, Who Shifted the Earth's Axis? The Alien Ship. However, we will still linger on one asteroid separately. This is the widely known in narrow circles asteroid Oumuamua. This is a difficult to pronounce name in Hawaiian, and in Russian translation it means something like scout or messenger in advance party. Actually, the whole essence of the subsequent hype is contained in this name. Because judging by its calculated trajectory, it does not belong to the solar system, but came from somewhere far away in interstellar space, from another star. In addition, it had a very strange shape, something like an elongated rock about 180 meters long and about 30 meters wide. According to other data, its length is about 230 meters. That is, in shape, it's closest to our aircraft carriers, although our earthly aircraft carriers are still almost twice as large. And nevertheless, such a small object was noticed. It was discovered by the Pan-Panoramic Survey Telescope and Rapid Response System Telescope System, located on the Hawaiian Islands. Actually, that's why it has a name in the Hawaiian language. Actually, the asteroid Oumuamua is practically the first interstellar object discovered in the solar system. Nominally, before it, there was one more called SNEOS 2014. However, everything is complicated with it, since it fell in the area of Papua New Guinea, and all known data about it is purely empirical. So, our elongated goose flew past the sun at enormous speed, performed a gravitational maneuver, and continued further into space. In January 2019, it crossed the orbit of Saturn and then left the solar system, leaving behind many mysteries. The version that gained the most popularity on the internet says that most likely it was an interstellar spaceship of aliens. This version still causes a lot of debates, and it's not surprising. If you want to distract public attention, give them something to think about and split them into two camps. People will gladly latch on to an idea, and while proving their point to each other with foam at the mouth, they'll lose the main idea and forget about the inconvenient fact. You can regularly observe this effect in any chat, even in my Telegram. Meanwhile, the passage of this asteroid provides many answers if you know what to pay attention to. So, the first important detail about the discovery of the asteroid: it was discovered in 2017 by the Pan-Panoramic Survey Telescope and Rapid Response System Observatory in Hawaii. The peculiarity is as follows. First of all, at that time, this observatory had not yet been fully completed. Out of the 4 planned telescopes, only one had been put into operation. The second was in the process of being commissioned at that time, and the other 2 existed only as paper projects. By the way, they still don't exist. But even with all 4 telescopes working, its resolution only allows us to see celestial bodies that are 300 meters in size or larger, and our asteroid is half that size. So, in other words, this observatory technically couldn't have seen this asteroid Yet for some reason it did. By the way, there's some confusion here as well. According to some sources, the size of the asteroid was estimated to be as much as 400 meters, then even 800, but now most tend to believe that its length is about 180 to 200 meters. The second oddity lies in the shape and composition of the asteroid. Astronomers believe that asteroids simply don't have such a shape, which in fact led to the hypothesis about its artificial origin. Adding fuel to the fire is its rotation along its largest axis, as well as its low albedo, that is, the reflective properties of its surface, which in turn may indicate that it is, at the very least, not made of stone. The third oddity is its sudden acceleration as it passed perihelion near the Sun. That is, it should have accelerated anyway due to the gravitational influence of our star, but at some point it sped up much faster than it should have, which again added fuel to the fire for the theory about the object's artificial origin. Although many astronomers still tend to believe that most likely, as the asteroid approached the Sun, it heated up so much that the internal gases, which had previously been in an icy state under its crust, burst out, giving the asteroid additional acceleration. Well, in my opinion, the theory is quite plausible. However, the oddities don't end there. One of the biggest oddities, in my opinion, is this. If you go to the National Aeronautics and Space Administration website and look at the orbit of this asteroid, it will be clearly visible that it came to our solar system at a steep angle from the northern hemisphere. Then it made a turn around the Sun and flew away again, once more into the northern hemisphere, somewhere in the direction of the constellation Pegasus. And the observatory that discovered it, with its only working telescope out of 4, is also located in the northern hemisphere. But if you read the articles dedicated to this asteroid from 2017, or even the current Wikipedia article, you'll find that astronomers, including Russian ones, calculated that this messenger came from a star cluster in the constellation Carina. And that's exactly the opposite part of the universe. And it's only visible in the southern hemisphere. Accordingly, the Hawaiian Observatory Pan-STARRS-1 could only see this part of the sky at the moment when the asteroid was passing through the plane of Earth's ecliptic. And of course, the trajectory of the asteroid's flight, as indicated on the National Aeronautics and Space Administration website, doesn't even come close to passing through the constellation Carina. Is this manipulation of facts, distortion of data, or just someone successfully launched fake? Which data should we trust? And it gets even more interesting from here. If we rewind the trajectory of this asteroid to the date it was discovered, that's October 17th, 2017. Then it suddenly turns out that it was discovered when it was already leaving the solar system, after it had completed a gravitational maneuver around the Sun and started to fly away. Wait, then what about the data on its approach, on its sudden acceleration near the Sun? After all, at that moment, it hadn't been officially discovered yet, and no one was observing it. Now it clearly smells like a blatant setup. No, seriously, look here. The asteroid was discovered already moving away from the Sun, meaning it had already undergone that very mysterious acceleration. So how could anyone have found out about it then? Yes, only in one way, by calculating its trajectory backward based on known physical laws. How else? But the laws didn't allow for the possibility to show its arrival from the constellation Lyra. Therefore, it was necessary to announce that the asteroid suddenly and inexplicably accelerated, even though no escaping gases or traces of a coma were visible from it. That is, this is clearly a case of data being adjusted to fit the desired result. And the goal of these manipulations is so important that no one is even bothered by the fact that, as a result, the whole world will consider this asteroid to be an alien spacecraft. Besides, it's unclear how an asteroid ejected from the constellation Carina suddenly approached us from the exact opposite direction. Of course, anything could have happened during 45 million years of travel, but the solar system is located exactly halfway between the constellations Carina and Lyra. No matter how much we spin around the galactic disk or around our own axis, in such a period, we simply couldn't have overtaken the star system, or Pineapple. Don't you think you're being misled? By the way, an interesting fact, about a year after this asteroid was discovered, in September 2018, the Federal Bureau of Investigation suddenly closed and sealed several solar observatories at once, including that very Pan-STAR-RS1. And besides them, 6 more similar observatories around the world were also closed. For example, the Shuar Observatory in Chile, the BRT Tenerife in Spain, the Mauna Kea Observatory in Hawaii, and the Canada-France-Hawaii Observatory also in Hawaii. The JET Observatory in Pennsylvania. All these observatories were observing the sun from approximately the same angle. Of course, all this was quickly explained by the threat of a solar storm approaching Earth, which could damage the equipment. But what is the connection between a solar flare and the Federal Bureau of Investigation breaking into offices? Personally, I don't understand. By the way, the official website and the webcam of the Pan-Panoramic Survey, Telescope and Rapid Response System Observatory are still not working. I think in this case, I don't trust National Aeronautics and Space Administration's website. It's possible that this object was discovered long before the official date and by a completely different observatory, and the Pan-STAR-RS1 telescope was simply made the scapegoat. And since astronomers and physicists love to turn data inside out, I showed that a bit earlier using the example of Lagrange points. That's why I'm inclined to believe that it really did come from the direction of the constellation Kelly. And now let's leave the constellation alone for a while and try to figure out how an asteroid in the universe can end up with such a strange, elongated shape, as well as a very unusual rotation. With your permission, I won't consider the alien spaceship theory, since there are already enough fantasists on that topic without me. Astronomers, according to the media, are convinced that such a shape of an asteroid in the universe simply cannot occur due to the physical laws by which these objects are formed. And in this, they are undoubtedly right. But what if this asteroid was formed differently? Those of you who are interested in space or just regularly watch my videos know what the Roche limit is. But I'll explain briefly. The thing is, gravity affects objects in space with different strength depending on their distance from the source of gravity. The closer to the source, the stronger the effect. That's clear. Therefore, for example, satellites in low orbit need much more fuel to maintain it. But the farther from Earth, for example, the easier it is for them to stay in the right spot without spending valuable fuel on regular orbit corrections. At a certain distance, the orbit becomes stable. The forces of gravity and speed balance each other out and cancel each other. But if the object is large enough, for example, an asteroid or a planet, then the difference in the gravitational effect on different parts of the object will start to show. A significant force gradient appears. The parts of the satellite that are closer to the planet experience a stronger pull than those that are farther away. And as a result, the object starts to get squashed and stretched. This is called tidal force. It affects all objects. Even our sun slightly squashes the Earth, which is why the Earth's equatorial diameter is a bit larger than its polar diameter. So, the Roche limit is the boundary beyond which gravitational forces will absolutely tear an object apart with the help of such tidal forces. This boundary is different for each object and depends on its radius and density or mass. But the mechanism of disruption is always the same. The part of the asteroid or planet closest to the center of mass experiences a stronger influence and is as if being pulled toward the more massive object. In this way, it's as if pieces are being pinched off from it. At the same time, the chipped off pieces receive a rotational impulse along the line of the force gradient. Gradually, the entire object is destroyed and turns into a ring of debris around the parent body, an accretion disk. This is precisely how Saturn's rings form. Now imagine that the planetoid is orbiting not around Saturn or even the Sun, but around a black hole. In this case, the general mechanism remains the same, but because of the colossal mass of the black hole, the difference in the force gradient between one side and the other side of the rotating planet will be hundreds or even thousands of times greater. And the process will go much, much faster and more violently. The difference in the gradient is so strong that the object simply gets stretched into a long sausage shape. This mechanism, by the way, is actually called spaghettification. That is, it is believed that you cannot fall into a black hole in one piece, because before that, with its gravitational force, using this very tidal force, it will simply stretch you out like spaghetti. Accordingly, if instead of you there is some planet on the orbit of a black hole, then it will be stretched as well. And if it enters the Roche limit, then it won't be able to escape anymore. However, if its orbit was originally elliptical, say, passing close to this limit near the black hole, then it will be torn apart by it. It is exactly into such a strips, stretched along the gradient line, that the asteroid will be torn apart, like an orange split into segments. These fragments will also receive rotational momentum along the same line. And some of the fragments, instead of being swallowed by the black hole, on the contrary, will receive an additional powerful acceleration, a gravitational kick, and will be ejected at tremendous speed beyond the black hole's gravitational zone. That's exactly how an elongated, sausage-shaped asteroid can appear, rotating perpendicular to its major axis. That is, there's no alien spaceship. Everything is much more prosaic and at the same time scarier. This rotating asteroid is simply one of the fragments of a planet torn apart by a black hole. And now, let's put together everything we've just learned. Odin. Cosmic telescopes, one after another, have been regularly observing the same small patch of the universe for the past 25 years. Located in the southern hemisphere, in the little-known constellation of the Flying Fish. And it's not just that there aren't any observers looking there. This is literally the primary target of observation. 2 images of a gravitational lens from that region, which are very clumsily being covered up by a galaxy cluster, even though other clusters do not produce such distortions. On the contrary, such distortions are produced specifically by black holes. And judging by the size of the ghostly sphere, this hole is very, very close. 3. An asteroid that came from the constellation Carina, which coincidentally happens to be exactly where the constellation of the Flying Fish is located. Look, strictly speaking, it's almost the same place. If the asteroid came, for example, from here, then with equal probability you could say that it came from the constellation Carina or from the constellation of the Flying Fish. It's almost the same constellation. The 4th. Strange circumstances surrounded the discovery of this asteroid. It was too small to be detected by the STARRS 14 observatory and was actually located in a completely different hemisphere. In order to discover it, you had to know exactly in advance where it would come from and wait for it. 5th. There were strange attempts to distort the asteroid's trajectory on the National Aeronautics and Space Administration website. 6th. There is unknown data about its acceleration as it passed by the Sun, even before it was discovered. 7. And finally, the shape and rotation of the asteroid suggests that it is a fragment of a planet torn apart by a black hole. Otherwise, it simply couldn't have formed in our universe. 8. The hype surrounding it almost seems to deliberately distract from the main idea that this is an alien ship. Isn't it a bit too many strange coincidences and, at the same time, inconsistencies? Let everyone draw their own conclusions. But personally, all this makes me think that the black hole wasn't just there, but that those who needed to know about it were perfectly aware of it. Its movements are constantly being tracked, while at the same time they try not to cause panic. And in general, that's the right thing to do. Panic is definitely not needed by anyone, but you always have to keep the threat in sight. Although such deliberately clumsy attempts to manipulate facts by high-tech companies, which include National Aeronautics and Space Administration, at the same time suggest that someone is still leaking this information. He who has eyes will see, to be continued.